All right, now we're going to the quotient rule. We've done the product rule. Now with the quotient rule, we consider the following examples of dividing radicals. So the first one we have square root of 4/9. Well, that's the square root of 2/3 times 2/3. So that's 2/3 squared. And square root of something squared is just going to give us just the 2/3. Or we could say, well, let's change that into the square root of 4 over the square root of 9. Well, the square root of 4 is 2, square root of 9 is 3. We have our answer that way. Both ways work, but that gives us the quotient rule for radical expressions. And again, a and b are real numbers. Nth root of a and nth root of b are both defined. B cannot be equal to 0. Then if we have the nth root of a over b, that's the same thing as nth root of a over the nth root of b. And this is going to make our life simpler because we can go either direction. We can go, that way, or we can go that way to whatever makes it easiest for the problem. All right, so we're supposed to simplify each radical expression, assume all variables are positive. All right, well, let's break it apart into the cubed root of 7 over the cubed root of 27. Well, we know that that doesn't break down, but this one is going to be 3 cubed, and so the cubed root of 3 cubed is 3, so it's going to be cubed root of 7 over 3. Same thing goes here. This will break down into the fifth root of x over the fifth root of 32. Well, 32 is 2 to the fifth, so that's just going to be the fifth root of x over 2. Okay, so this is how we can break it down to make it simpler, to make it so we can actually solve the problems. Now, what about this one? Well, now we have, one radical over another radical, but neither one of them we can take a nice square root of. So let's bring them all together under one radical. Well, now we can say, well, 90 divided by 10. Well, that's 9. Square root of 9 is 3. So it makes it easier this way going the opposite direction. Over here, it was easier to break it apart. Over here, it's easier to put them together. Same thing goes here. Let's put them together. Those y's look like they're going to cancel. Boom. Then we have the square root of x to the fourth, which is just going to be x squared. Okay, so you have to kind of pay attention which way is going to make things easier for you and make life a lot nicer. All right, same thing. So now we're taking the fifth root of that. So again, let's break it apart, numerator, denominator. Now we can break it apart pieces and pieces. And so we have the fifth root of 32 times the fifth root of x to the fourth over the fifth root of y to the fifth. Well, that becomes just y. That just becomes 2. And we have this. So we have 2 fifth root of x to the fourth over y. And that's our answer. Okay, so we broke it apart into, the radical over radical, and then we broke this radical into a radical times a radical, and then we simplified as much as possible to get to here. What about this one? Now we have x minus 1, the square root of, times square root of x plus 1. Well, we can bring those under one square root and multiply it out. Now, in this case, it doesn't say to multiply it out, but you can multiply it out, and you'd have x squared minus 1. And so that would be your final answer. Okay, so sometimes if they don't say it says simplify, so that sometimes simplify is factor, sometimes simplify is multiply out. So these two, if it was on either one of those, should give you a good correct answer depending on how they define simplify. So that would give it in a factored form, so you can't go any simpler. And this is multiplied out, so it's simplified and there's no multiplying left to be. So that's kind of one of those. Simplify is kind of a hard thing to think about what that means in this case. What about this one? Well, now we have a cube root of this over this. Well, let's put this over this under one cubed root. We'll probably factor this into what, x plus 3, x plus 2. Guess what? Our x plus 2's cancel, so now we have the cubed root of x plus 3. So here we had to factor, and then we had to cancel, and then we got our final answer. So we took two pieces together, then we brought it under one cubed root, and then canceled, and we got our final answer. All right, so that's all I have for starters here, so hopefully that will help you get started.